By now you're familiar with solving systems of equations like you see right there. And the way you've learned to do it so far is take each of these equations, graph them, and see where they intersect. And the intersection point x comma y is your answer for x and y. You also know about the substitution method, and this is our third method, the elimination method. And as we go through this, take a look at these 3 bullet points because we're going to be kind of following those steps. It might be good for you to copy those down on a sheet of paper and work these examples with me as I do this. It's always easier to know math by doing it rather than watching someone else do it. My first bullet point says look for addition or subtraction matchups. So we're going to work on this addition example first. And here's what I mean by looking for an addition or subtraction matchup. I look for the coefficients that have the same number value. I'm not worried about positive or minus yet. So for example, the x has a coefficient of 4 and this x has a coefficient of 3. That's not a good matchup. Well, in the second term, we have a 2y and a negative 2y. That's a good matchup. So I found a good matchup. When I look at this other example we're going to do shortly, I see the x's share the same coefficient of 3, so that's a good matchup. The y does not have a good matchup. So once I've found a matchup, I ask myself, would I have to add or subtract to make that y term go away? So really what I'm thinking in my head is 2y plus negative 2y or 2y minus negative 2y. One of those two is going to do a good thing for me. If I take this one and add to it this one, 2y plus negative 2y equals 0. That's something I like. 2y minus a minus 2y is like 2y plus 2y. That gives you a 4y. You'll see why I don't like that in this situation. So when the signs are different, I'm going to choose addition. Now I'm going to go ahead and add just like I'm adding numbers. 4x plus 3x is 7x. 2y plus a negative 2y is 0y. I'll go ahead and write that, but you will probably eventually stop doing that. And then a 10 plus an 11 is a 21. Well, 0y is just 0, and in an equation you don't bother writing 0 normally, so I'm going to just replace that with 7x equals 21. So here was the point. By finding that I had matching coefficients, one positive and one negative, I knew that adding was going to make that y term go away and leave me with a very simple equation. So if you look for the matchups and you choose the right one, addition or subtraction, in this case I chose addition, then you will end up with a resulting equation that is really easy. 7x equals 21, I can solve that. I just divide the left by 7, I divide the right by 7, and I get x equals 3. I'm halfway there. I have now solved the resulting equation. And the final step is to plug into any of your original equations to get the solution for the other variable. So as you know from the substitution method, you can choose any original equation. So I'll just choose 4x plus 2y equals 10. And this is going to be my plug-in. And at that point, I know x is 3, so I can rewrite this as 4 times 3 plus 2y equals 10. I'm now skipping some of the steps that you would normally see, like subtract 12 from each side or divide 2 from on each side, and I end up with a y equals negative 1. So I have a final answer of x equals 3, y equals negative 1. That is my solution to that system, and if you wondered if that was accurate, you could plug these in and it should work for both of those equations. Now if you think back to the original problem, I said I was going to choose addition, but let's find out what would happen if I would choose subtraction for this case. 4x minus 3x would be 1x. 2y minus a minus 2y, that's a little complicated. 2y minus a minus 2y is like 2y plus 2y. And 10 minus 11 is negative 1. Well, this would make me sad because what I was hoping for was either my x term or my y term would go away. And it didn't, so that just tells me I made a bad choice. When I chose addition, my y term went away, leaving me with an easy equation to solve. All right, let's take a look at this next example with subtraction. And again, we'll be following these same 3 bullet points. I look for addition or subtraction matchups. Like I said earlier, the y's are not matched up with their coefficient, but the x's are. So in this case, I would say, should I add or subtract? If I added, I would get 3x plus 3x equals 6x. That's not very good because I want the variable to go away. This means I need subtraction. 3x minus 3x is going to be 0x. But here's a big warning. This subtraction, people tend to remember it for the first term, and then they forget about it, and they go on to this next term and they say, oh, 8y and 2y, and then they write 10y. That's not the case, and I'll show you why here in a second, so I suggest putting these parentheses on your work. This tells me 3x minus 3x, 8y minus 2y. That's a 6y. You can put a positive there if you'd like. But 8y minus 2y is 6y, and 80 minus 50 is 30. So if I just clean that up a little bit, I write 6y equals 30. So I've looked for my addition or subtraction, I've chosen subtraction, and now I have a simple equation to solve. 6y equals 30. If I divide each side by 6, I get y equals 5, and I'm halfway there. The final thing is just plug in to any equation you want. You can take the top one, you can take the bottom one. Let's take the bottom one just for giggles. And this is going to be my plug-in. And we already know y is 5. So now what I've done is I've just built myself a really easy equation to solve. Move the 10 over to the other side, divide by 3. I get, oh, we lost some viewing there. I get 40 thirds, or 13 and 1/3. So my final solution here for this system is x equals 13 1/3, y equals 5. Plug those into those equations and it should work for both of them. Let me finish out with a scary problem. It's going to be using subtraction, but I've probably told you in class many times that subtraction and negatives are your enemy in algebra. And look at all the negatives in this example. And we're going to choose to do subtraction because my matchup variable, my y, which has coefficients of 8, when the coefficients are of the same sign, we're going to choose to subtract to make them go away. If you choose the wrong one, remember, you can figure it out because when you get to this step, if one of the variables didn't go away, you done did screw up. 5x minus a minus 3x is like 5x plus 3x. So that's 8x. Remember what's happening there is 5x minus a minus 3x minus a minus is like plus a plus. All right, now over here I have negative 8y minus a negative 8y. Well, minus a minus is like plus a plus. So this is negative 8y plus 8y, which is 0. That's good. Then negative 49 minus a minus 9 is like negative 49 plus 9. That's negative 40. So the purpose of this problem was to show you this subtraction can get you. So you got to be careful. I've went ahead and worked out the rest of this problem, and it's probably good for you to pause it and see if you can work it out and get the same answers. Now this is the end of this video, but I'm leaving one thing out of the elimination method, And what that thing is multiplication. There's going to be another video that's going to show you how multiplication can work its way into this scenario.